Okay, it's my pleasure to introduce Damian Shelton. Damian? Oh, there you are, good. He's the CEO and co-founder of Agility Robotics. Damian joined Agility Robotics as CEO in early 2016, initially focusing on the tech transfer and seed funding efforts. He is currently focused on building out the sales and manufacturing capabilities of Agility's first product, Casey. Prior to joining Agility, he was co-founder and CTO of Three Rivers 3D, where he led the technical development effort that resulted in a commercially successful line of low-cost 3D scanners. Welcome, Damian.
Okay, well, good afternoon. I'm excited to present Agility Robotics. We build a dynamic robot called Cassie. Our vision is that robots have a lot of interesting things to do outside of constrained environments. And by that, I mean environments that were designed for people and not for machines. It's been possible to automate lots of tasks for many years if your environment is designed for the machine. And our assumption is that there are lots of other things that you can do. I have a couple of examples of these for things that require you to be able to operate in a human environment. And we think that our approach is more versatile than existing methods of outdoor operation. That would include wheels, tracks, and wings. So good examples of tracked vehicles are like iRobot's PackBot. There are a lot of aerial drones now that would fall under the general wings category. And Cassie, shown here, is our first product. To answer our most common YouTube question, no, this is not a render. This is an actual robot. Cassie's about yay high. And I'll show you a video of Cassie now. And this does have sound on it. Okay, so that's Cassie. One reason why I got really interested in this about a year and a half ago, and I'll give you a little bit of backstory on the company later, was looking at the recent interest in last mile delivery. There are two general classes of solution that have been proposed to this. The first is wheeled vehicles, and I'm not trying to pick on Starship Technologies because they've done some amazing work. But wheeled vehicles have limitations. You can't easily climb stairs. For delivery applications where you have to reach a counter or do material handling, it's challenging because you end up with a robot arm kind of mounted on top of a wheeled vehicle and the center of gravity isn't ideal. More importantly, from our perspective, is that crossing uneven terrain can really be a challenge. So, a lot of delivery environments are not well-structured factory environments. They're outdoors with things like toys in front yards and so on. Aerial drones like the Amazon Prime Air device have a limited flight time. I don't know about you, I'm not excited about ordering some dog food from Costco and having it flying in the sky at 100 miles an hour above my house. The FAA also turns out has something to say about that, so the regulatory environment has been a little bit hostile. These are classic Pittsburgh pictures, which are our high-quality infrastructure supported by our enormous tax base, and then houses that have very interesting access. And there are lots of areas in the country that are like this. San Francisco is an old city too. There's lots of places that are only really accessible by people that we don't really think about unless we're confined to a wheelchair as a result of an injury or a disability. So our philosophy is actually to focus on dynamic behavior as opposed to trying to match a specific behavior programmatically. And I have a high-tech demo. So I'm a roboticist by training. I've decided to invent a clock. And the way I decided to do this is to attach this phone charger to a cord. And my idea is that every time it swings back and forth, I'll count it, and that's going to be my clock. So as a roboticist, I put a 1 kilohertz control loop up here with a sensor and a really nice low inertia actuator. And then I have a computer sense it and say, okay, I'm going to make the thing move back and forth. And here's my clock. Now, obviously, the easier way to do this is just let it go and swing back and forth. In this case, physics is driving the system. And an interesting characteristic of this clock is that if I whack it, it comes back to its timekeeping. So there's no sensing going on with this. I'm not actively controlling it. And I can recover from disturbances and add energy to the system with it behaving based on physics rather than based on computer programming. Our saying is that you can't program a rock to fly even if you have really, really great code. So that was demonstrated with this robot Atreus here at the DARPA Robotics Challenge a couple of years ago. And it was a really great science demonstration, but was not such a great product. If it fell over, it would have broken, and that would have been the end of Atreus. So that was the motivation for Cassie. Cassie is power efficient. We have between 8 and 10 hours of battery life for mixed standing and walking, which is longer than it takes to walk up to somebody's front door. We have about a 10-kilometer range at a 5-kilometer-per-hour operating speed. Cassie was designed to fall on its face, so the carbon fiber face of Cassie has already hit the pavement at walking speeds. And it's human scale, safe to be around. It's about 30 kilograms. Mikhail, shown here, is one of our co-founders. I can't easily lift Cassie, but Mikhail works out more than I do, and he can load it in the cars just fine. Our go-to-market strategy is to sort of climb a ladder to verticals. We considered whether we wanted to stay as a stealth startup and develop the technology in the backside of the company and have a very minimal public exposure. Decided that the way to do this was actually to treat this as a mature product from the get-go and take our lumps on the manufacturing side. So looking out, a couple of years, by the end of 2019, we want to be doing sort of iRobot, PackBot performance, 50 to 150 units a year. We're already at our sales target for this year, which was 5 units, and growing slowly. So these are all proven companies: Mecca, Boston Dynamics, iRobot, and then hypothetical FedEx bot from the Will Smith iRobot movie. The interesting thing with the logistics market is how large it is. It's a $35 billion a year labor market just in the US, and that's only labor that's associated with curb to doorstep delivery. That's not any of the back end logistics on the supply chain. That's what it costs to get packages from a UPS or a FedEx truck up to your front door. So where are we now? We've sold 3 Cassie 1.1s. We're going to be delivering those in June this year. We have a better than 50% gross margin in quantity 1. 8 employees, 6 of whom are full-time. We're funded through mid-2018 on a mix of seed funding and profits from sales, and targeting our Series A for this summer so that we can expand. So I founded the company with Jonathan Hurst, who's also a CMU grad. Both of us started in 2001. I've known him the entire time, so we go back 16 years. Mikhail Jones was one of his first students, was responsible for getting Atreus working. So basically a team of the smartest PhDs in the world tried to get Atreus working for the DARPA Robotics Challenge, and Mikhail came along, drank a bunch of coffee, and got Atreus working sort of single-handedly with a master's degree. So I refused to let him get a PhD, grabbed him and stuffed him in the company, and now he's working with us. We have a worldwide exclusive license to the technology underlying Cassie. We have a 5,000 square foot facility in Albany, Oregon. I'm actually based in Pittsburgh. We're hoping to start a Pittsburgh office to do more computer sciencey things as we move forwards. And our first customers are academic customers that are going to allow us to both gain experience with field deployments and also curate a hiring pool. There's not a lot of people available to hire who are legged robotics experts out there, so we'd like to own all of them. Moving forwards, we like to think of Cassie as the Model T of bipeds. If you ask people what the first car was, they'll say it's the Model T. Of course, it was not the Model T. There were cars close to 100 years ago, or 100 years prior to the Model T. But we think that we have one of the first bipeds that's designed for low-cost production, has a clear path to getting out there to be used and abused in the real world. And Cassie is an evolving platform. We're focusing on products, not demos. So we don't do demos. We only sell Cassie robots, and hopefully you'll see one delivering a package to you in 3 to 5 years. Thanks.